Okay, so in this lecture I'm going to cover some of the security, privacy and legal issues that are relevant to commercial websites. So first I'm going to cover the security issues, then the privacy issues, and then the legal issues. So there's many threats to commercial websites. So if you build your own e-commerce website, it's going to be vulnerable, and it's going to be vulnerable partly because you've got lots of customer data, right? Heaven knows how much customer data Amazon or Google or whatever have, but it's an awful lot. And customer data is valuable because people can steal the customer data and clone someone's identity or use their credit cards to buy other stuff and so on and so forth. Commercial websites are also vulnerable because they're generally based on a similar culture, similar technology, what's called a monoculture. So heaven knows how many websites are built with a LAMP stack, with Linux, Apache, MySQL, and PHP. So if you find a nice sort of juicy vulnerability in Apache, let's say, you can hack an awful lot of websites, and the same is true of Linux, same true of MySQL, and same true of PHP. Commercial websites can also be vulnerable because they can be, there's a potential for political controversy. So I'll give you an example of why people try to attack Amazon for that reason. So who are the people who pose these kind of security threats? Well, obviously there's kind of criminals who want to steal your data or whatever, but also governments. Governments are quite keen to kind of have access to everything they can possibly get their hands on. And then you've got a more sort of blurry category here, which consists of sort of activists or freedom fighters or terrorists, depending on who you are, really. So, people who might be, people who sort of radical vegans, right, might be trying to hack, to bring down commercial websites that sell meat, for example. And I'll give you an example of the Syrian Electronic Army, who are sort of somewhere between these two categories here. So criminals will want to hack your e-commerce website because they want to steal your credit card details, your bank accounts, and other personal information. So if they can clone your identity, apply for a mortgage, get 100, 200,000 pounds or whatever, they'll be pretty chuffed, right? Another use, maybe they're going to use your machines and email accounts to send spam. So if they hack into your web server, they can send spam from that web server. They might also do this kind of extortion kind of attack. So one kind of extortion is what I'll call described later, denial of service attack, where they basically stop your website, anyone from being able to use your website. And you also have this kind of ransomware stuff where they encrypt the hard drive. So, if you haven't backed up your database, they can sort of encrypt everything on your server and stop it from working. There's also been some rather sort of, dubious examples of theft of intellectual property from companies. So if you're foolish enough to store your intellectual property on your public web server, then, it could potentially be nicked. And governments, love to sort of, snoop on the personal data. It's not just sort of, the communist bloc in the 60s, right? Britain in our own times has, its various nefarious, laws that let the government, read all your data and all the rest of it. Governments also are known for stealing intellectual properties. I'll give an example. Governments often hack into computers as part of criminal investigations. They've got various toolkits for that, which were recently publicized with some kind of leak, WikiLeaks thing. And the governments are only too keen to make security weaker, so trying to ban strong encryption, introduce backdoors, etc., to facilitate their own access. Often this backfires, right? You introduce the backdoor so the government can get into it, and guess what? Someone figures out how to use that backdoor who's not a member of the government, right? So, not particularly keen on this kind of meddling myself. So I'll give you a couple of examples. So the Chinese government's got rather bad reputation. Maybe it's cleaned its act up recently, but has a rather bad reputation for stealing intellectual property from other governments and companies. US government, all this notorious WikiLeaks stuff, right? US government was like spying on Angela Merkel, among other people. Well, there's NSA leaks, right? Stuxnet, malicious computer worm was built by America and Israel to sabotage Iran's nuclear facilities. And, the CIA booby-trapped some software that was nicked by the Russians. They knew it was going to be nicked by the Russians, or the US, the Soviets at that time. So they booby-trapped it, and it led to an explosion in the Siberian gas pipeline. So there's lots of cyber war going on, and governments are spending an awful lot of money these days to, be sort of build up a good armaments or weapons in the cyber warfare. And then we've got this blurry category of activists, freedom fighters, and terrorists. So, one man's freedom fighter is another person's terrorist, and often, who's who, changes over time depending on, whether they're helping the Americans or not helping the Americans, or helping the Russians or not helping the Russians, so on and so forth. But these kind of people do denial of service attacks against websites, deface websites to raise political issues, and the Syrian Electronic Armies, sort of nice example of this. So these are governments who are supporting these are hackers supporting the government of Bashar al-Assad. So they defaced, websites of Syrian rebels, Western websites. They used malware to find Syrian rebels. They spammed websites that have pro-Bashar comments. And they spy on technology and media companies. So they're kind of fighting a cyber war on behalf of Bashar al-Assad. Now, what are the weapons that all of these agencies can use against each other? Well, we've got physical attacks, social engineering, denial of service attack, and compromise of computer in a variety of different ways. So the physical attack's kind of the easiest, right? If I want to hack the web server of an e-commerce company, this is the best way to do it, I think. You walk into the company headquarters with a fake ID. Now, the way to walk into a company HQ is to carry a large box, right? Because there's there's a kind of built-in politeness to most people who will hold open the door for someone carrying a large box. So, so this is where the tailgating comes in. So, normally you have to swipe an access card to get through into the company HQ, particularly after hours. But if you carry a large box and follow someone in, then they're going to they're going to hold open that, very conveniently hold open that box so you can get through security. And then maybe you've got like a badge saying, IT, maintenance or something like that. So you work your way into the company looking like a serious person with a large box. You plug a USB stick into an employee's computer or just some kind of like mini computer into the server room, for example. And then you walk out in the Wi-Fi cafe across the road. You can access the intranet remotely. So getting into the intranet may not seem such a big deal, but once you've got, but there's an awful lot of security that exists between the company and the external world. And if you can get past that with a little computer that you just plug into the main sort of intranet, then you're sort of quite a long way towards success. And if you've got a USB stick plugged into the employee's computer, you can probably do key logging, get their password, and all that kind of stuff. Then you've got social engineering. In this case, you're trying to manipulate the employees into giving the information that you need. So Middlesex, had a lot of emails recently about successful social engineering attacks that were carried out. And this is how you do it. So the simplest way is to phone up, say there's an issue with their account, pretend to be like the IT administrator or something, and ask the person to confirm their email and password. Now you might think, well, no one's going to be dumb enough to give their username and password over the phone. Well, some people are very good at manipulating social situations, making people feel afraid, and a good proportion, if you phone up 10 people, you're going to get 5 of them probably to get their username and password if you're good at this kind of social manipulation. You can make it even easier if you send them an email beforehand that says, next Tuesday, as part of our routine security check, I'm going to be phoning you up to check, to run through a few basic questions. So that kind of primes the employees to receive this kind of call and makes them more likely to be compliant with it. Now, the way to protect against these kind of attacks is obviously to educate company staff, make them aware that you'll never phone them up to ask about their username and password, tell them not to hold the door open for people with large boxes and so on and so forth. You educate the security personnel, again, make sure everyone who goes into the company is checked. Don't just sort of sit there reading the paper while people stroll by in the morning. And obviously, if you can engineer, this education's all very well, but people forget it most of the time. Even better, you kind of engineer physical access points to make it harder to tailgate, right? So instead of having just a door that lets everyone into the company, you have like one of these kind of turnstile things, so that each person has to validate their card in order to get into the company. It's easy to copy the appearance of a card. It's harder to copy the chip that's typically used to let people into companies. And if you want to prevent people phoning up and doing the social engineering attack, then you minimize the information about your employees that's visible outside the company. So when you're phoning up, let's say someone, in marketing, let's say, getting them to give you their username and password, then firstly, you need to find that person in marketing. More importantly, you need to pretend to be someone in the IT department. Now, you could wing it and say, I'm John from IT, but it's much better if the name that you give them corresponds to the name of the IT person that actually exists in the department. If you're lucky, they'll know about them, but they'll never met them. So again, if you hide all this information inside the company so you can't find it from outside, then it's going to make your company more secure. So next kind of a sort of attack I want to cover is what's called a denial of service attack. And denial of service is what it says. You're trying to stop the commercial website from operating, or more generally stop a computer system from working. Most frequently used, this type of attacks refers to the blocking of network communications. Obviously, it could be like I take a sledgehammer and smash the computer into bits. That would be a denial of service attack. But this is the more usual form it takes because it's harder to get to the computer with the sledgehammer. So we're maybe going to cause the server to crash, or maybe we're going to flood the servers with packets. So this is the most common form, and it's very common still today. So crashing servers, back in the good old days, you could send a malformed packet to the server, and that would cause it to fall over and die. It was really kind of easy because they had some bad software libraries running on these old operating systems. So if you send them the ping of death, then it would just fall over and die because it didn't know how to handle a large ping packet. Or a teardrop attack, you send them some kind of complicated mangled IP fragments, and again, the operating system would have some badly written libraries that would cause it to crash. These days, I don't think there's much of that. So you can, as long as you've got the latest operating systems and patches, you can generally avoid this kind of crashing server attacks. Much more common and much easier is to overload the server with requests so that legitimate customers can't get through. So obviously, if you just sort of, click refresh a lot on your page, you're not going to bring down Amazon with that, right? So what people usually do is they use a large number of machines, typically machines that have been compromised in some other way, and this is called a botnet. So this is a botnet, like a large number of machines that you've hacked into in some other way, and you instruct these machines to hammer the web server with packets. And you can get more fancy. You can get this like reflective denial of service attacks that let you amplify the amount of data you're sending to flood the web server. I'm not going to go into all the details here, but this is sort of how it works. So we have a botnet because you can't do it, as I said, pressing refresh on your browser is unlikely to bring any kind of website down. You have to do this more systematically. So generally how this works, you use some kind of virus, some kind of other attack, like a sort of, some kind of way in which you can crack into the browser, or by sending, open this file with an exe in it, some kind of other way of compromising the computer. So you compromise other computers, and you install some software in those other computers, which we're going to talk about later, and then that gives you control over these other computers. And then you have your attacker here, and he's got some kind of controller system, some kind of internet relay chat, something like that. And then that instructs all these other machines to all send packets to this victim here. So you can imagine if you've got 100,000 machines hammering a single computer, that's going to prevent the computer just won't be able to cope. The Apache server, whatever is running on there, just won't be able to serve all of these requests. And so if you've got a legitimate customer trying to get through with all this web traffic, they won't be able to get through. Your website will fall over and die, and no one will be able to reach it, and you won't be able to sell anything, and you'll lose money. So Spam House is anti-spam organization were targeted by distributed denial of service. Anonymous decided they didn't like Amazon because they stopped hosting WikiLeaks, but because Amazon's got such a huge content delivery network, it didn't have any effect. And the UK government was accused of using DDoS attacks against hacking groups, Syrian Electronic Army. So if you've got a huge botnet, you can try and make money by launching a massive DDoS attack against a company, and then threatening to do it again unless they pay you some money. And if the company's making, £100,000 an hour by selling stuff on their website, and you can bring it down, then they might be willing to pay you £10,000 to keep it online. So, this kind of extortion or blackmail kind of thing is often what this sort of thing's used. It's a tricky attack to protect against because it's an internet scale problem, right? Your website running from servers in London, let's say, is going to be receiving packets from China, from Russia, from America, and so on and so forth. Everywhere in the world can reach your website. So it's an international problem for starters. You can't just if it was someone in the room next door, you could go and, complain. But since it's potentially a problem from anywhere in the world, and these botnets can be highly distributed, it's not a sort of national problem. The only real effective way of defeating a distributed denial of service attack is web caching on a large scale. So I'm going to mention this in the next lecture, talk about how Akamai works, but Cloudflare is another one. So they're basically distributing your website's content across a couple of 100,000 servers, and that makes it impossible to bring down with a botnet of only 100,000 servers. You need like 1 million or something like that, right? Firewall could be used to block the packets, but you'd have to, but then the firewall itself is a piece of software that has to run, and if you're hammering that firewall with 100,000 packets every millisecond or whatever, it's going to get overloaded. So that's distributed denial of service attacks. Now we're talking about how can we actually break into the computers? This is part of the problem of how, so people can use these kind of attacks to hack into your server, and they can also use these attacks to hack into your local machine or whatever as well, right? So we can have buffer overflow attacks, we can have SQL, no SQL injection attacks, and we can have backdoors as well. These are different ways in which your server facing the internet can be hacked into by people who want to control it, get the data off it, and so on and so forth. So the buffer overflow attack, I don't know how, I think there might have been one with XP recently, because there was a bunch of machines were all brought down with some kind of XP vulnerability, and it might well have been a buffer overflow attack, but in general, this is a little bit less common with modern operating systems such as Windows 10, because they're kind of aware of it and they've got various things of randomization and so on to make it harder. But this is the general idea. Within a particular operating system, you've got a bunch of different libraries, and some of these libraries, especially the old C libraries, used to have some really serious vulnerabilities. And these C libraries didn't sort of correctly check the data that they were processing, so they ended up, if you were copying a string, for example, it would just keep copying until it reached a certain symbol. But if that symbol wasn't present at the end of the string, it would just keep copying and basically corrupt the whole memory. So you could use these vulnerabilities to execute arbitrary code on the server. So, there was the SQL slammer worm quite a long time ago that, just basically went boom, across the internet, 75,000 machines in 10 minutes. So I'm not going to go into the details really, but you've got some kind of vulnerable library. That library, it's called smashing the stack often sometimes. They basically, instead of sending it just entering a string in a web form or passing a string to a web service, you pass a sort of long line of what's called no ops, no operation. This is like assembler code. And then at the end of that, you pass your program. And because the library is not bounds checking, it copies everything you send into the memory until it ends up copying the program that you've sent into the executable part of the memory. And it'll have some kind of jump command that will let it jump into into the code and then execute it. So you're basically sending a server, you don't have access to that server, but you send it this long list of assembly commands containing a program, and if the libraries aren't checking that string carefully, they can end up copying that program into the memory of the computer and then executing that, all without any permissions. So, and then you can run your own program on the remote computer, and that can be a little server which you can then use to install some kind of malicious software on the system. So the problem is less serious than it was, but I said I've got a hunch that the XP stuff was linked to a buffer overflow attack, but I haven't checked that. So the best way to protect it is to keep your operating systems up to date. So if it was a buffer overflow attack on the XP, then obviously XP is ancient, right? It's not surprising it had some vulnerabilities, whereas Windows 10 apparently wasn't subject to those vulnerabilities. You can also use a firewall to hide unnecessary services. So if you've got a computer running MongoDB, maybe MongoDB's got a buffer overflow vulnerability, right? So you don't want to expose your database port to the public internet. You can also get hardened operating systems. You've got hardened BSD. So if you're really paranoid, you can run your server on a hardened operating system that's much less likely to be vulnerable to these kind of attacks. And obviously you can run an antivirus, etc., so that they can check for, if someone running a malicious program, you can pick it up with the antivirus. Next it comes to SQL injection attacks. Now these are probably the most likely class of attacks that your e-commerce website's going to be vulnerable to. So I'm going to talk about SQL. I know I'm not teaching SQL in coursework 2, but it's still relevant, so I'm going to mention it. But there's also no SQL attacks, which I'm going to talk about as well. Now, so these you would really need to think about, because any kind of e-commerce website that you create, you have to protect against this. It's fairly easy to protect against these, but if you don't, your entire database could be extremely vulnerable. So these attacks work in the following way. The attacker enters some malicious SQL into the form of a web browser. So people can enter stuff into forms, like input fields, right? They can click submit, and what they can do is enter just malicious SQL in there. If we don't adequately check for SQL statements, the attacker can execute the SQL on your database and give them full access. They can delete the database, they can steal the data, they can do anything they like with their database if you don't carefully check the input. And remember I talked about using PHP filter input, and the reason for that is to protect against these kind of attacks. So I'll give you a little example. Suppose you've got a server-side script, so if you know a little bit about SQL, which you probably do, Suppose the user's logging in, right? They type in there, they've got their username and password fields, so they enter the username, and then we have a statement here on the PHP saying select all from users where name equals. Now, under the usual case, it'd be select all from users where name equals username, because we're getting the data of that user. But suppose, instead of username, they type or 1 equals 1. They type in the username or, they type in the close quotation mark and then or 1 equals 1. So if they type that into the browser instead of just their username as they were expecting, as the script was expecting, then what you end up with is an SQL statement that looks like that. It's going to select all from users where name equals dir, so that condition is going to fail, but this condition is always going to return true. 1 equals 1 is always going to be true. So in that case, it's going to select a complete list of usernames. You obviously need to fine-tune this a little bit for the PHP script you're attacking, but the basic principle is you stick in a bit of your SQL, and then that SQL will be executed by the user, by the script, if it doesn't adequately check what you're entering in the browser. You can execute multiple statements. So in the server-side script, we've got the same server-side script. We've got select all from users where name equals username. But if instead we type A with a close quotation mark, and then with SQL you can have separate statements with a semicolon, and then we could have drop table users, select all from user info where T equals T, and so on and so forth. We can append a whole list of SQL statements to the data that we're entering just in the browser, and they'll all be executed on the server. So obviously you've got to try different things because you don't know that they're called, that you haven't got a table called user info, but people tend to use the same names for tables and so on and so forth. So these attacks have been remarkably successful. So if you want to hack the database and deface a website, this is a classic way of doing it, right? You just manipulate the data in the database so it says, save the rabbits or whatever, some kind of like vivisection website, whatever. Now, that's with SQL. You can do exactly the same thing with no SQL. It's called no SQL injection attack. So suppose we've got a login page that checks the username and password. So in our login page, we're entering the username and we're entering a password, same idea. And in the code, the PHP script, we've got dbusers.find, username, my username, password, my password. All very sensible. Do you think, well, how could that possibly go wrong? So this will return a single user. And then let's suppose we've got another loop down here that outputs the user info. Yeah? This will return a single user if my username and my password are in the database, right? So we should just say, we log in and it says, hello, David, or whatever, right? But suppose we replace username and password with this, right? So this is you probably remember from the earlier stuff from MongoDB, this is the greater than symbol, and then this is the quotation marks. So in this case, it'll return all of the users whose username is greater than empty string. So this is like an alphabetical greater than, so that'll include all of the names in the database, and whose password is also greater than empty string. So all non-empty strings are greater than GT with an empty string. So this search command will return all users. So then we could actually, if we had a login page, for example, and we guessed that there was some admin user called admin or root or something like that, then we could we could enter the password as curly braces with the greater than that, and that would be just dropped. If we didn't check it carefully, it would just be dropped into our bit of code, and we get admin access to the database. So again, very easy attack to run. You don't need to do clever stuff with assembly code and libraries and operating systems. All you have to do is type in some appropriate bits of SQL or NeoSQL into the browser. So to protect against this, you need to validate the user input extremely carefully. Just as a precaution, you should always use JavaScript to check the input, because that's better for the users as well, make sure they're entering the correct details. But this doesn't really protect you, because what will really protect you is using server-side scripting language as PHP to check that the input's not malicious. So you need to do the PHP filter input stuff, or more sophisticated checks, to make sure that what you're getting from the user is, doesn't contain any of these SQL or no SQL injection attacks. Because if you only do it client-side, that doesn't protect you because the user can still create like an HTTP post message or an HTTP GET message, without using a browser at all, and without running any JavaScript. So the JavaScript's not really going to help you. It's only useful for, more useful for the users than protecting your website. To protect your website, you must carefully, rigorously check the input that you're receiving, make sure it's not malicious. You can also limit the privileges. So the regular customer or the script running the website shouldn't be able to delete the entire database, for example. Try and limit your privileges as much as possible, and I discussed that in the second lecture on MongoDB. Right, so another way in which people can hack your server is through what's called a backdoor. In this case, we're modifying the code to get remote access to the machine. So this is typically modifying the operating system code. So with open source projects, anyone can modify the code, right? I presume anyone who likes can contribute to the Linux kernel if they so wish. And in fact, someone did try and add a subtle backdoor to the Linux kernel, which was detected. But who knows, what governments or whatever have successfully inserted backdoors into the Linux kernel. Entirely possible. Many, many people in this world would love to have a backdoor in the Linux kernel, right? So I'm sure many attempts have been made. And proprietary software, so Windows, can be modified by insiders. And again, many, many governments would love to have a backdoor on Windows because there's a lot of Windows servers out there as well. So your governments often request backdoors, probably figured out ways of remotely accessing most operating systems. So unless it's something like hardened BSD, regard it with suspicion, I guess. So once you've got a backdoor, that means that you can remotely get into the server without any kind of privileges or passwords or anything like that. And then you can install malicious software on the computer. So the backdoor will let you install malicious software and any other security compromises such as attackers, viruses, worms, physical attacks, and so on will end up putting some software on your computer. Now the software that's installed, malicious software on your computer, is sometimes called a rootkit. And a rootkit is a specific kind of software that's subtly hidden in the operating system. So some viruses always do their best to hide themselves somewhere obscure, but a rootkit generally takes this to another level. Because what a rootkit will do is it will manipulate the operating system so that if you just try and find the rootkit, it'll be impossible. It'll kind of lie. It'll misreport file sizes, give incorrect lists of open ports, and so on. So you'll no longer be able to trust what the operating system reports to you. So if you try and look for the rootkit file, it will sort of be invisible to you without actually scanning the disk with some kind of other software tool. So the rootkits can be extremely difficult to detect and remove. And there's a rather notorious example of Sony installing a rootkit, some part of its digital rights management stuff. If you get a rootkit or some kind of malicious bit of software on your server or your home computer, then it can record all of your keystrokes. It can do screen capture, can do all kinds of stuff and send them back to a controller system. It can extract data from the hard drive, can encrypt the hard drive. So there's a whole bunch of ransomware attacks a couple of months ago. It can also turn your computer into a zombie that can be used to run other attacks, like send spam and all the rest of it. People store all kinds of unpleasant and illegal files using this kind of software as well. So update antivirus software and try and prevent anyone hacking in the first place. So firewalls play a role in protecting against this kind of stuff. You can block access to the ports. You can prevent software from communicating with the internet on other ports. If you've got a keylogger, you want to stop that keylogger from sending your keystrokes to Russia, for example. But firewalls have their own vulnerabilities, and you can have this kind of tunneling effect where a keylogger communicates through ADA, pretends to be a standard web browser. Sending GET requests, but actually it's sending your keystrokes to Russia, let's say. Another way of protecting yourself is with intrusion detection systems. These sort of sit in your network, listening to all the network traffic that's going around, and look for particular signatures of worms, viruses, and so on and so forth. When I worked on the Safeguard project with Swisscom, they had the problem that they were using Snort as it happens, and it generated loads of false alarms, and this is a total nightmare for them. And if you're generating too many false alarms, then your intrusion detection system is effectively useless because you can't figure out the true from the false. Intrusion detection systems also, they can't work with encrypted traffic. I mean, you can do kind of pattern analysis where you look at the connection patterns and so on and so forth. That can tell you something with encrypted traffic, but you can't actually look inside the body of the packets. Probably one of the better ways to test your security, if you're running a company, e-commerce company, let's say, is you do what's called penetration testing or pen testing. What you do is you use security tools to try and break into your system, or better still, if you've got a bit of money and it's worth spending the money on this, you hire a specialist to do this. So they will analyze your website, analyze your company, and try all the different ways of breaking into it that the various governments, hackers, and all the rest of it would also use. So it could be part of a full security audit. So full security audit should always run, if you're running a proper company, you should run this at least every year, I'd say. And you do all the penetration testing, vulnerability scans, check all the access controls to the system, the operating system, the applications, physical access, router configuration, firewalls, and what's going to happen if it all goes pear-shaped and you lose everything, right? You need a disaster recovery procedures as well. So every year, at the very least, you should run a full security audit on your company, check all this stuff, or preferably have it checked by a professional to minimize your vulnerability. So in this course, I haven't covered storage in the cloud or computing in the cloud and so on and so forth. But I'm going to say a little bit about it because most companies are sort of moving towards the cloud for a variety of reasons. And so it's worth thinking about security as it applies to the cloud. With cloud storage, you get this sort of slightly uncomfortable division of responsibility between the customer and the service provider. And this depends on what kind of service you're using. So if you're using, so with the cloud, you can hire sort of physical machines, you can hire kind of virtual machines, and you can hire services that run on the cloud, like storage, data storage, and there's probably some level up from that as well. So yeah, if you have you can even have like applications that run on top of that as well, right? So always been a little hazy on this, but yeah, so this is like infrastructure as a service, so maybe virtual machines or whatever, platform as a service. It's maybe if you're using like using databases in the cloud, for example, and software as a service, maybe that's using some software that's using this platform, that's using this infrastructure. Main point here is that depending on the level at which you're using the cloud, you'll have different levels of responsibility. So for example, if I'm hiring a database in the cloud, then I'm responsible for the access, securing my password and all the rest of it, but I'm not responsible for the operating system that the database is running on. That's the cloud service provider. Whereas if I'm hiring a virtual machine, then I've got more responsibility for its security. And if I'm hiring a physical machine, then I've got even more responsibility for its security. So it just depends on how much you're actually using, what level you're using the cloud. If you're trying to protect yourself, you can use encryption. And encryption's a sort of double-sided sort of thing, really. On the one hand, it can make it harder for certain kinds of attacks. I haven't covered it, but like man-in-the-middle attacks, for example. You can protect yourself with encryption. You can also protect your data with encryption. But if you encrypt everything to death, you can't really understand what's going on in your network, and you can't use intrusion detection systems. So, and also, encryption is only as strong as your web mechanisms for protecting your keys and passwords. If your employees are going to respond favorably to someone who calls them up and says, give me your username and password, then obviously encryption is not going to help you at all, right? So encryption is sort of also handy in the cloud because for a variety of reasons, we might want to encrypt the data in the cloud to prevent it from being accessible if the cloud is compromised, and I'm going to talk about that in the next section. Obviously, we want to encrypt our communications between the client and the cloud so that someone can't sniff the data out. So use like SSL or HTTPS. And we might also want to encrypt the data on the clients, depending on what we're doing. That might also be beneficial. So one thing also to think about if you're running a commercial website is customers' passwords. So obviously, it's going to be massively vulnerable if customer enters their password and you just store it in plain text in the database. It's vulnerable because employees can use that password to pretend to be that customer, and it's also vulnerable because anyone who can hack into using an SQL injection attack, for example, could hack into your database and then have all the passwords of all the customers. So what people usually do is when you enter your password, they don't store the plain text version of the password. Instead, they use a hashed version of the user password. And a hash, or a cryptographic hash, is it converts a piece of text into a sort of a random string of characters, and there's a unique mapping between each piece of text and each hash that's generated from that text. So when you log in, they apply like a cryptographic hash function, convert that password into a meaningless string of characters, and then when they log in, they enter the same password, they apply the same hash function to that password, and that should convert it into the same meaningless string of characters so we can check to see if they entered the correct password. And all that we store in the database is a hashed version of the customer's password. So if someone steals our database files or whatever, then all they can see is the hashes, they can't see the original passwords. Trouble is, though, with cloud computing and GPUs, you can actually crack standard passwords very quickly. You can just do a brute force attack where you try all possible character combinations, run them through the same cryptographic hash function, and compare them with the hashes in the database that you've stolen, and so you can actually crack them pretty quickly. But it's more secure than doing it just storing plain text. You can also use permissions to limit the damage that could be done by mistakes and attackers, set policies that allow different types of data to be accessed by different people. So, obviously administrators are going to need to access everything, and they have a super secure password. And then the customers only access their own data, and employees can access customers' data, but not each other's data, and so on and so forth. So again, try and restrict what each person can do, enable each person to do their job, obviously, but don't enable them to do more than their job, because then you're introducing extra risks to your system. The most important thing to realize is that there's no perfect security method. Some might tell you, if you use encryption, or, if you use snort, you're going to be totally protected. And, these are 20,000 reasons for believing that this security method is absolutely perfect. Well, it's never the case. There's always, always something going to go wrong with your security. Assume that there'll be multiple things going wrong, okay? You need to secure in depth. You need to use all possible security mechanisms at all possible levels of your system, and they'll make it so hard and tedious for an attacker to break into your system that they'd have to be a well-funded government to actually achieve anything. So secure in depth, and don't assume that any security methods can be perfect, and test your security regularly using security audits. Okay. So that's the security side of things. Now I'm going to go into the privacy side of things. So some people are, a little bit, precious about their privacy, you might say. Privacy is some kind of inalienable human right. They just, resent any attempt to, find out anything about them, whatever. Other people don't really care about their privacy, share anything they like online, don't care how things are processed, don't care how their data is used. All they want is to be able to use stuff online, and they don't really care about the privacy implications of that. And the police obviously claim that you don't need privacy. Put a camera in your bedroom as long as you've got nothing to hide. They're all trained professionals looking at all your data, so you should just let them have access to everything. So, this is, Orwell's kind of 1984 kind of scenario, right? So, there's many different perspectives on privacy. That's what I'm trying to highlight here. I'm sort of somewhere in the middle, I guess. So if you want to be really private online, you can do it. Don't share any data, don't create accounts, don't use Facebook, don't use Gmail, access web pages with Tor, which I'll tell you what that is, and make payments with Bitcoin. So you can be private online, but it's going to take a certain amount of effort, and it's going to have certain kind of compromises to it. So what we have, Tor, is a peer-to-peer software that lets you communicate anonymously online. It's used by freedom fighters, non-governmental organizations, corporations, criminals, governments, lots of different people who want privacy online. And this enables you to contact a web server, and the web server, if you go through Tor, the web server won't know which machine you're contacting them from. So you can access public websites without being tracked. So the idea here is Alice wants to browse, Bob's website or buy something from Bob. So what she does with Tor, it sets up this sort of path through like a large number of kind of routing machines. Can't remember something Tor nodes or whatever. Yeah, Tor nodes. And it sets up a random path through these nodes. So Alice communicates through this path to Bob. So what Bob sees is an HTTP request from this machine, and he has no idea where that came from because Bob can't trace back the path through all these different machines. So obviously there's no limit. So this means that Bob doesn't know anything about Alice, but that's only true as long as Alice doesn't say, hey there, Bob, I'm Alice, right? So if Alice here creates a Facebook account and shares all her stuff, then Tor is not going to provide any protection against that. Tor only provides protection if you're, basically if you're pulling data from the internet, it'll enable you to do that anonymously. Now, within the sort of debates on privacy, there's also debate about how you can buy things online, right? So cash, in general, has a high level of privacy, right? If you put on, some kind of monkey mask, whatever, wear gloves, walk into a shop, and pay for something with cash, then the person who's selling you that thing, if they'll sell something to you wearing a monkey mask and gloves, that person won't know anything about you, really, right? It's got a high level of privacy if you pay for things with cash. On the other hand, if you pay for things with credit cards, PayPal, and so on, then people governments, banks, or whatever can track who you are, your name, address, all the rest of it, along with the location of the purchase. If you have a cash security breach, you lose a finite amount of money. If I lose my wallet and it's got 100 quid in it, I lose the 100 quid, right? Whereas if I lose my wallet and it's got a credit card in it, then I could potentially lose a great deal more than that. And that's true of bank details, be a lot worse, right? So people are interested in privacy and possibly for other reasons as well. Also generally interested in cryptocurrencies, which the sort of, the granddaddy of them all is Bitcoin, which is a peer-to-peer cryptocurrency. You have this kind of use of computer power to generate new units of currency. It's sort of not controlled by any government, and you can buy online you can buy things online with some sort of degree of privacy if you want to. So here we have an example of an e-commerce website that's extremely private. It uses Tor hidden service. There's somewhere running websites within Tor. Again, highly anonymous. So you can have private hidden services within Tor, and you buy stuff with Bitcoins. In this case, in the case of Silk Road, the privacy is implemented because it's a marketplace for illegal products, such as drugs. You can hire someone to kill your wife, all the rest of it. But if you wanted to create a legitimate e-commerce website that had a high level of privacy, then you could do it using these kinds of techniques. So again, it's the usual. People can do bad things using privacy. People can do good things using privacy. It just depends on who you are and what your agenda is. And as it happens, Silk Road was shut down, and they prosecuted the person, whatever. And you often hear of copies of Silk Road flourishing for a bit and then being shut down, and the customers moving elsewhere and so on. So it's a constant cat and mouse game with governments and websites like this. So next thing I want to cover in relation to privacy is the EU legislation on cookies. So we've got a whole 10 marks in coursework 2 is for customer tracking and recommendation. And so I want to say something about the EU laws that relate to customer tracking and recommendation. So EU legislation on cookies, which also applies to HTML local storage. So protects users' privacy. Prior informed consent is required for storage and access to information stored on a user's computer. So in other words, you have to agree to the use of cookies or local session storage. It's the same thing, effectively. So if you ever, which you have, I'm sure you've seen millions of times, this annoying pop-up thing at the bottom of lots of pages that says, we're using cookies to provide statistics, blah, blah, or we're using cookies to improve our site, whatever it is. And what you typically do is click, get rid of that stupid annoying thing, I want to look at the website, right? But by EU law, if they're doing a particular kinds of tracking of your behavior on the website, they have to display this notice, and you have to agree to the use of cookies when you're using that website. Not all uses of cookies are covered by this law. So if we're using cookies for user inputs, not quite sure what that means, but if you're using for shopping carts, for example, if you're using HTML session storage to run our shopping cart, that's fine. I don't have to get the customer to agree to it. If I'm using the cookies to manage logins, sessions, and so on, then again, the customer doesn't have to agree to that. And if I'm using cookies to customize the user's experience, so the user might have font preferences or language preferences, again, I can store data relevant to the user without doing the annoying pop-up thing. But if I'm using them for tracking, recommendation, building up statistics on the browsing history, and so on and so forth, then I need to get the explicit consent of the customer. You can do this pretty easily. There's a JavaScript kit that's available you can use to add a cookie consent banner to a page. So you can download it there, I think, and there's another one there. So you don't have to implement this from scratch. You can just get one of these kits that are already out there and just tweak it a little bit to match your own requirements. In general, regardless of your views on privacy, it's a very good idea indeed to store as little about your customer as possible. Not only will this benefit their privacy, but it will decrease the damage if a security breach occurs. If your shopping website unnecessarily stores the date of birth, mother's maiden name, national insurance number, sorry, and then the website gets hacked, you're going to lose a whole lot more data. Then the customers are going to lose a whole lot more than just the use of your website. They're going to potentially have their identities cloned, have their bank accounts stolen, and all the rest of it. Whereas if you didn't need that information, if you don't need that information, just don't store it, okay? Because it's going to massively decrease the damage if a security breach occurs. I'll just run through this quickly because it's not super relevant, sort of kind of relevant, but not super relevant. So with cloud storage, you've got a whole load of extra issues with management of privacy. So if you're storing your data in the cloud, then the company could be badly run, employees could access the data, the company could mine the data that you're storing in the cloud, and it could share your data with the government. So you really need to understand how the cloud provider is going to use any data that you store on the cloud. Now, so privacy, as I said, people have different opinions on it, and different websites, typically operate with different levels of privacy. Silk Road, pretty private. Facebook and Google, not at all really. They're mining your data to death. Now, a low level of privacy is fine as long as the user agrees to it, right? So you typically have a privacy policy or general policy that includes some privacy statements, and the customers agree to this policy when they use your website. So there's a bunch of terms and conditions customers agree to when they sign up. Most people don't read it, right? Who can be bothered to read 20 pages of closely worded legalese, right? So there was like an example of some privacy some terms and conditions in which people sold their souls to the devil as part of their agreement to the use of the website. But at least you're covered when customers complain, because you can point to your terms and conditions and say, well, you signed up to this. So if someone says, hey, I don't like the fact that you shared my data with Amazon or whatever, then you can say, well, in the terms and conditions, we said we'd share your data with Amazon, and you signed that. If you didn't bother reading it, it's your problem, not our problem. And obviously, if you're using a cloud service provider, your company's privacy policy should take into account the policy of the cloud service provider. Unless you're encrypting data on the cloud, in which case it's a bit different, but if you're storing data in free text on the cloud and the cloud mines it, then you need to make the users aware that that might happen. So most people, the people who don't care about privacy, they don't care about it because it just sort of happened, the sort of loss of privacy is sort of limited to the space of the internet, right? I'm sharing some data, it's mined on some servers, and that maybe affects my subsequent internet experience, but it doesn't affect me as I'm sort of hanging out at the bar with my mates, right? So the information that you share online is rarely brought into day-to-day life at the moment. But with face recognition, it's no longer the case. So with face recognition, I can tie your face as you're walking around, with your mates or whatever, playing football, hanging out in the pub. I can link their face in the wild, in the real world, with data you shared online. Because I can match your face, as I'm looking at it now, with your face as it appears on a dating profile, for example, your face as it appears in your work website, your face as it appears on Facebook, or your face as it appears on Twitter, and quite how the mood works, but whatever, So I can link, what you're doing at this moment with everything that's contained in your internet history. And people have built systems that work in this way. So this is, some kind of demo. I think it's Carnegie Mellon. I think someone hoovered up the Russian equivalent of Facebook and, turned it into a fast way of matching, real faces with data from there. So with face recognition, you can link, people as you see them in the world with their data online. So, one of the projects I proposed, which no one took up, was a sort of scanner app that would, you use your mobile phone and you take a picture of someone, and then it would show you, whether they were single or what their job was and all the rest of it. So, or you could even make it augmented reality, right? Color people pink who are single and blue who are married or something like that, right? So you can link. So in the age of face recognition, we either have to give up on old-fashioned ideas about privacy, say, well, that is who I am. I am the person who's on this dating website. I am that person who works in this job, and so on and so forth. An age of transparency, would be this first option. Or you can modify your face to defeat face recognition. So people who are paranoid about face recognition, about privacy and face recognition, have come up with a variety of solutions. So, if you're some kind of notorious criminal who's appeared in lots of newspapers, and you want to avoid all that data about you being linked to your face as you walk about in the world, maybe you could wear like a cage on your face, and that would kind of prevent you being recognized by these kind of face recognition systems. Of course, the cage might be itself, appears a little sinister, but if maybe you want to try some kind of face recognition defeating makeup, or some kind of funny glasses with lights. But if you want to avoid this link between your face in the wild and your data online, maybe you want to look into one of these kind of approaches. Ooh. Okay, cool. Right. So, last thing I want to talk about is legal issues. And there's a lot of legal issues. If you're running an e-commerce website, you need to think about a lot of different things. And it's very different from just building an e-commerce website as part of, some piece of coursework. You need to think carefully about all these security, privacy, legal stuff before you move it into the real world, because there are real, serious penalties for messing this stuff up in the real world. So the kind of legal issues you might get is if your sensitive customer data has been stolen from your database, customers might upload illegal content, cloud provider might share your data with the government, and these events will happen. They happen a lot. So you need to be very clear about the legal liability before these events happen, because they will happen. So you need to understand what the consequences are and what you will do when these things happen. Now, the thing to be really aware of within the EU is this idea of personal data. So a lot of these legal issues relate to what's called personal data, and the Information Commissioner's Office has these criteria for personal data. Well, this is just some examples, right? The full list is much more details here. So personal data means that a living individual can be identified by the data provides information about that individual, the data could be used to inform actions about an individual, and the data maybe concentrates on the individual as a central theme, and the data has the potential to impact on an individual in personal, family, business, or professional capacity. So this sort of questions, if they're answered in the affirmative, would mean that it's what's called personal data. And there's a set of very specific laws that apply to personal data, but don't apply to data that doesn't fall under data that isn't this kind of type of data. So if you lose personal data, there's some serious consequences to it, right? You can have someone can steal your identity, you'll lose your privacy, it can impact your family, business, and so on and so forth. So to give some examples, so there were 37 million personal records stolen from the online cheating site Ashley Madison, right? So in this case, clearly, well, there's potential for identity theft. Clearly, people who are on Ashley Madison, they don't typically want to be discovered, so they're losing their privacy there, and that has negative impacts on their family, business, etc. When your wife finds out that you're on Ashley Madison, typically your family, life can take a little bit of a hit. And, the 47 million credit and debit card numbers from TJX, similar idea, right? You're losing more likely identity theft, loss of privacy. Well, who really cares if you bought that pair of trousers? But, maybe you're going to lose some cash as a result of the loss of your credit card. Now, if you lose data loss, if someone hacks into your website, for example, using a NoSQL injection attack, you've got to notify the affected individuals. You've got to assist the affected individuals. You've got to potentially compensate them for harm and associated distress. So, my loss of my wife as a result of the hacking of Ashley Madison, I probably signed up for some disclaimer anyway, but, clearly I might expect some compensation for that. I'm going to lose customers, right? Who's going to sign up to Ashley Madison after they had all their data nicked? You're probably going to have to get that data back from someone. If someone's deleted your database, you've got to obviously have backups. And you can even have really big fines, right? You can have fines of up to £500,000 if you have a really serious data loss. So it's really serious stuff, and it can have really big implications on your company. Now, with cloud providers, the issue gets more tricky, right? Because you're storing stuff in an anonymous server farm somewhere or other, so you don't have full control over the data. And in this case, you get this kind of blurry division of responsibilities between the cloud provider and yourself, and the legal situation is pretty much unclear. The best you can do is check that your cloud provider has sensible policies in place for managing your data. So there's this idea of an ISO 27000 certificate, which basically says that the company conforms to, has, a systematic approach to managing sensitive company information. So if it's got one of these certificates, it's probably a good thing. You're going to have a contract with the service provider, and ideally you're going to specify things like who owns the data, is there any insurance, what's the backup, so on and so forth. You might be able to get a special contract, but not likely with a big company. You're stuck with the default contract most likely, but you can shop around to find companies whose data management conforms to the sort of expectations that you have. Another issue, legal issue, if you're running a website, is illegal content, right? So suppose you're having a website where people, like Facebook, where people can upload stuff, or Dropbox, another example. So people can upload ripped films, stolen credit card information, more unpleasant stuff. Now, in some companies, you're held responsible for data uploaded by the customers, but the EU has some very sensible liability protection for hosting providers. So you don't have liability for uploaded contents if, you don't have liability under EU legislation as long as you have no knowledge or awareness of the illegal nature of the content, and that you remove or block that content after you gain knowledge of it. So in the case of the EU, if someone uploads something illegal, you're not liable as a company as long as you don't know about it, as long as you get rid of it, once you're made aware of it. So governments, love to poke around in your data. They can request data from cloud providers, potentially without your knowledge. They can ask telecommunications companies to retain data. So the, rather unpleasant bits of legislation, such as the UK Patriot Act and UK Investigators Power Bill. Now, a further thing which is highly relevant to your e-commerce websites is this legislation governing the transfer of data abroad. So there's this EU directive on data protection that prohibits the transfer of personal data to non-EU companies that do not meet the EU standard for privacy protection. So if you've got some personal data, this is why the personal data definition is important. You've got some personal data on about EU citizens in your database. Then if that database is within the EU, that's fine. But you can only take that data outside of the EU if it's going to a place that has what's deemed an acceptable law, or it's going to the USA, or other conditions are met. So if you've got personal data on EU citizens, you can move that around the EU, no problem. And you can go to a non-EU country. Well, in general, the transfer from an EU to non-EU country is generally not okay. So for example, Australia and Hong Kong are deemed to have inadequate data protection laws. So if you've got personal data from EU citizens, I can't store it on a server in Australia, and I can't store it on a server in Hong Kong, at least at the time of recording these lectures. So if I had data in a server in Ireland, I can't move it to a server in Sydney. That would be illegal. Now, the USA has a sort of agreement with the EU so that I can store EU personal data from EU citizens on servers in the US because they've got this so-called safe harbor scheme. But there's serious problems with it. It's more like a fig leaf to allow data to be exchanged, but it doesn't really mean that the US has adequate data protection laws. Now, the tricky thing with this is many companies refuse to say where your data is held for security reasons and explicitly rule out holding it only within Europe. So Google's like this, and that's going to create problems if, for example, someone accesses your customer's data from a server in China, for example. Could create all kinds of problems. So just be a little bit aware about that. Nice thing about using Amazon Web Services are that you can specify which servers you want to use. So you can choose a server in the US, you can choose a server in Ireland, and probably other countries as well. So with Amazon, you can explicitly control where you want to store your data, whereas with Google, I think there's some issues with that. Yeah, come on. Right. All right, got it. OK. So within coursework 2, I've just given you a lecture on security, privacy, legal issues. Within coursework 2, I want you to describe the security, privacy, and legal issues that apply to your e-commerce website. So I've just given you all this stuff, right, about security, privacy, legal issues. And that's kind of a long lecture. I want you to think about your e-commerce website you built and suggest and identify some of the issues that I've covered and explain how they apply to your website. I'm not expecting you to solve these issues, okay? I'm not expecting you to rigorously check for no SQL injection attacks. I'm not expecting you to, engineer physical access to your system, whatever, any of that. But I want you to think about, let's suppose your e-commerce website is, working in the real world. Maybe talk about distributed service attacks. Maybe talk about injection attacks of various kinds. Talk about some of the legal issues that apply to the customer's data, some of the privacy issues, maybe about a page, something like that, to get a full mark. So as I said, describe the issues, but I'm not expecting you to solve them. Right. So this lecture's all about security, privacy, legal issues affecting commercial websites. And the next lecture is going to be a sort of summary of some of the other websites, things that are very highly relevant to building commercial websites. So applying to all three pieces of coursework, really. Things like content delivery networks, ways in which you can monitor customers' behavior on a website, search engine optimization, things like that. So kind of covering some of the other bits that you need to fit into the sort of e-commerce website puzzle, I guess.